Now that we know how to find the power of a complex number, we want to go in the other direction and find complex roots. Our example here asks us to find the 2 square roots of 4i. Notice that when we're finding square roots, we're going to have 2 answers. If we were finding a cube root, then we would have 3 answers. If we're finding a 5th root, then we would have 5 answers, and so forth. Just understanding that principle right there can help you with the overall big picture and help you keep in mind what you need to do. Now, just like when we were finding powers, when we're finding roots, the theorem that we're going to use only applies if we're in that polar form. So we need to take the rectangular form of this complex number and convert it. We could use our calculator, but this one is very simple to get all the information just off of a quick sketch. So I'm going to go ahead and do that. There is no real part in 4i, so I'm not going to go in the horizontal direction from the origin at all. I'm going to go 4 in the imaginary direction, a positive 4. So the length of that vector is 4, and the length of that vector is my r value. Remember that r is always positive. Now the theta for that complex number is the angle that's formed by that vector in the positive x-axis right there, so that angle is going to be 90 degrees. So rewriting 4i in its polar form is going to be 4 CIS 90 degrees. We haven't found a root, we've only converted. Now we're ready to find the root. And for each of our 2 solutions, for each of our 2 roots, we're going to have the same r value. And the way you find the new r value for the roots is to take the square root of the r value that you had before. So my r value is going to be 2. Now there's also an angle component. So I'm going to take my theta from my trig form, which is 90 degrees, and I want every coterminal angle to it. So I'm going to add 360 degrees times some integer that I'm going to call k. Now since I want a square root, I'm going to divide every part of this by 2. And that's going to give me a formula for my new thetas. The 90 divided by 2 is going to be 45. And 360 divided by 2 is 180. And I want to multiply that by k. Now k is going to be an integer, and we're going to start with k equal to 0. Always start counting with 0. And then k equals 1. I'm going to have 2 solutions. So those are the only 2 values of k that I need. If this was a cube root, then I would have k equals 0, k equals 1, and k equals 2. So your last value of k is always 1 less than whatever your root is. All right, so now I have a formula for each of my thetas. My first theta is going to be when k is equal to 0. If I let k be 0, then I have 45 degrees plus 180 times 0, which means just 45. And then if my second theta is when k is equal to 1, if I let k be 1, then I have 45 degrees plus 180 degrees times 1. 45 plus 180 is 225 degrees. So these are my 2 thetas for my answers. Taking the r value that I found of 2 and my angle of 45, I can write my first solution in polar form this way, 2 CIS 45. And to find the next one, 2 CIS 225. So in polar form, those are my 2 roots. Those are the 2 square roots for 4i. Notice that my instructions tell me that I need to write this answer in rectangular form. So now we just need to convert this, which was what we did primary work in 8.2. So this should be a review. Remember that the CIS 45 stands for cosine 45 degrees plus I sine 45 degrees. So when I multiply 2 times cosine 45, I get square root of 2 over 2, plus I sine 45 is square root of 2 over 2. And if I simplify that, write my answer down here, I get square root of 2 plus I square root of 2, because the 2's are going to cancel. Now when I get out of quadrant 1, and I look at 225 degrees, you have to be careful and remember that you are in quadrant 3, where the cosine and the sine are both negative. So pay attention to your SIG ends, your pluses and your minuses on this. I still have a reference angle of 45, so cosine 225 degrees is negative square root of 2 over 2, and then minus I sine 225 degrees is negative square root of 2 over 2. And simplify that answer, and I get negative square root of 2 minus I square root of 2. So in rectangular form, those are my two answers. I'm going to take a quick look at the graph of these roots. So here's my coordinate axis right here, and let's use the trig form right here, and let's graph these vectors. R is the length of the vector, so my length is going to be 2, and then I'm looking at an angle of 45 degrees, so that vector would go out in this direction, somewhat like that, so this is 45 degrees. The length of that vector is the radius of a circle, which would be 2. And then if I graph the other vector, it's going to still have a length of 2, but the angle is going to be 225. 225 is 180 degrees away from 45, like that. So this larger angle right here is 225. The 180 you'll recognize and remember from right here. That's what we were adding to our first angle to get to the second. Anytime that you have a square root, you're going to be adding 180 degrees, because when you take roots and you graph them, there are always going to be vectors that are equally spaced in one revolution of the circle. So two vectors are always going to be exactly 180 degrees apart. If you have 4 vectors, they're always going to be 90 degrees apart, because that would be 360 divided by 4.